And a very good day to everyone. So here we go. We proceed with the next subsection of sampling theory, which is sampling distributions. So what is the definition of the sampling distribution? It is a theoretical distribution that shows the frequency of occurrence of values of some statistic computed for all possible samples of size n drawn from some population. In the meantime, the sampling distribution of the mean is a theoretical distribution of the frequency of occurrence of values of the mean computed for all possible samples of size n from a populations. So basically, there's a difference between the sampling distribution and sampling distribution of the mean, which is denoted by the frequency of the distribution. Okay, so this is an example of the sampling distribution of the mean. So we have the scores here. So it can be depending on the number of n, which is n2, 4, or 36. So the distribution of the sampling is different subjected to the number of the n's. Yeah, because we can see here that this is the relationship between sample size and the shape of the sampling distribution of means, which is A is the frequency distribution of scores in the population, B is the sampling distribution from sample of size 2, and this one the sampling distribution of sample of size 4, and this one is sampling distribution from the sample of size 36. So we can see the difference as the sample of size increase, so it become more elongated, right? Especially in terms of the peak. So sampling distribution of means and standard error of the means. So basically, this can be defined by this figure, which is the population mean, because we can see here that as it goes to the right, so it is the error plus 1, plus 2, plus 3, and this one is like going backwards, and it's going to be negative 1, 2, and 3. So next one, we're gonna have the sampling distribution of the mean. Okay, when the population is normally distributed, so basically if we define shape, which is regardless of the sample size, the distribution of the sample means will be normally distributed. So this is really important criteria if, let's say, the population is normally distributed, right? So next one is center, meaning to say that the mean of the distribution of sample means is the mean of the population, meaning to say that sample size doesn't affect the center of the distribution. And next one is spread, which is the standard deviation of the distribution of sample means, or the standard error is defined as such. Okay, the standardizing a sample mean on a normal curve. The standardized z-score is how far above or below the sample mean is compared to the population mean in units of standard error, mean to say that how far above or below, mean to say that sample mean minus mu, and in units of standard error divide by this equation. Okay, and in the meantime, the standardized sample mean can be defined as sample mean minus mu per standard error, which can be defined as such here. Okay, so next one is the probability distribution of the observation x1 until xn is sometimes called the population, and this distribution is the smooth histogram of the variable x for the entire population, as we mentioned previously. And the population is unobserved unless all observations in the population have been observed. So it's a histogram computed from the observation x1, x2 until xn give an estimate of the population. So as such here, so we include it in the form of the histogram. A statistic computed from the observation is also a random variable prior to observation of the sample. A statistic is also a numerical quantity whose value is determined by the outcome of a random experiment, meaning to say that the choosing of a random sample from the population that you have done or you have conducted for your final project. So the probability distribution of statistic computed from the observation is sometimes called is sampling distribution, whereby this distribution describes the random behavior of the statistic as below. And it is important to determine the sampling distribution of the statistic. It will describe its sampling behavior. The sampling distribution will be used to assess the accuracy of the statistic when used for the purpose of estimation. So, sampling theory is the area of mathematical statistics that is interested in determining the sampling distribution of various statistics. And many statistics, it is worth to note that have a normal distribution, and this quite often is true if the population is normal, meaning to say that it is also sometimes true if the sample size is reasonably large, because there is the central limit theorem, which will be mentioned in the next video. Okay. So in the meantime, if we want to combine the random variables, so quite often we have two or more random variable x, y, z, etc. And we combine this random variable using a mathematical expression, right? Through mathematical modeling, for example. An important question: what is the distribution of the new random variable? So example, suppose that one perform two independent tasks, A and B. X is the time to perform task A normal with mean 25 minutes and standard deviation of 3 minutes, and in the meantime y is time to perform task B normal with mean 50 minutes and standard deviation 2 minutes. So let t equals to x plus y, which is the total time to perform the two tasks. And so what is the distribution of t, and next one is what is the probability that the two tasks take more than 45 minutes to perform. So the next example is suppose that a student will take 3 tests in the next 3 days. So mathematics, which is x, is the score he will receive on his test, and English literature is defined by y, which is the score that he will receive in this test, and social studies is defined by z. So assume that x has a normal distribution with mean mu as standard deviation 3, and y has a normal distribution with mean 60 and standard deviation of 10, and z has a normal distribution with mean 70 and standard deviation of 7. So we can get this graph. So this is the distribution of the graph of the, if we combine the random variables. So this is the sampling distribution of the figure that we can observe. Suppose that after the tests have been written on overall score, S will be computed as follows, meaning to say that S is overall score equals to 0.5x plus 0.3y plus 0.2z and plus the 10 bonus mark. So what is the distribution of the overall score, which is S? So this is we learned about sum, difference, and linear combination of random variables. A linear combination of random variable xy is a combination of the form, meaning to say that L equals to ax plus by plus c, a as a constant, where a, b, c are numbers positive or negative. Most common is sum equals to x plus y, the difference equals to x minus y, and others, meaning to say the average is 1 over 3 x plus 1 over 3 y plus 1 over 3 z, sorry, and weighted average is defined as according to the proportion. So the means of a linear combination, if L equals to ax plus by plus c, and the mean of L is the mean of L, and the mean of x and the mean of y. So most common is the mean of x plus y and the mean x plus mean x. If let's say the mean x minus y, there is going to be mean x minus mean y. So the variance of linear combinations, so if x, y are independent random variables and L is defined as such, so the variance should be variance L equals to variance x b squared variance y, and the most common to be variance x plus y, which is variance x plus variance y, and the constancy has no effect on the variance, so that's the condition, which is DC. So example, suppose that, okay, so this is the previous experiment, yeah, sorry, the previous example, right? 25, 15, 45, 5, 15. Yeah, okay, this one. So f x and y are independent. So t equals to x plus y. Total time is normal with mean. Mu is 25 plus 50, which is 40. And the standard deviation can be defined as such. So what is the probability that the two tasks take more than 45 minutes to perform? So it can be defined as such, mean to say that if let's say the t is longer than 45 minutes, so it can be computed to be 0.0825. So uh, in the comment section, can you answer, or maybe you can give an idea and about this question, or how can you relate this first task and this one, so until you get like 0.0825. So maybe the right, just learn from that, just learn from the available data that we have here. So 43.6 and 45, so which is this is 45. Okay. Okay, try to figure out. Okay, next one is uh, for the example 2. So determine the distribution of S, which is the 0 0.5, 0 0.3, 0 0.2 plus 10. So S has the normal distribution. As such, mean to say that the total is 87 and the division is 3.635. So basically, this is the principle of random variable. If let's say you want to edit, or maybe you can add it up and then you can make it into minus. So this is the total distribution of S if we combine X, Y, and Z. So I think this is the repetition. Okay, normality of linear combination. If x, y are independent normal random variables and L plus ax plus by plus c, then L is normal with mean mu plus a mu plus b mu plus c, and standard deviation is defined as such. And so in particular, x plus y is normal with the mean x mu x plus mu y with the standard deviation stated there. And x minus y is normal with mean mu x plus minus mu y, which is the standard deviation is defined as such. So the distribution of the sample mean, the distribution of average, which is the mean, let x 1, 2 until n denote n independent random variables, each coming from the same normal distribution with mean and standard deviation. So let the expression to be like that. So what is the distribution of x? So the distribution of averages or the mean, because the mean is a linear combination, so it can be defined as such. And after that, you can derive into this. And for the next term also, you can define accordingly until you get this simplified version. So thus, if x1, xy denote n independent normal variables is coming from the same normal distribution, then this one can be defined as such and has normal distribution with the mean mu equals to mu, and this mu equals to this mu, and the variance is defined as such, and standard deviation is defined as accordingly. So this is the graph of the behavior of the data, which is the probability distribution of the mean, and this one is probability distribution of individual observations. Right. So summary is the distribution of the sample mean x is normal, and distribution of the sample mean has exactly the same mean as the population, and the distribution of the sample mean has a smaller standard deviation than the population, which is comparable to that and averaging tends to decrease variability, and external file is illustrating the distribution of the sample mean. Okay, right. So I think after this we will learn more about central limit theorem. So see you later. All right. Thank you for your time.